What if I told you that the way aircraft cross the Atlantic Ocean has undergone a revolutionary transformation in just the past 3 years? While nearly 1,500 flights still traverses oceanic expanse daily, the rigid highway system that once governed these journeys has largely disappeared. Today's transatlantic aviation represents a fascinating blend of cutting-edge technology, climate adaptation, and the persistent challenge of safely navigating one of Earth's most demanding flight corridors. Gone are the days when aircraft followed identical predetermined tracks across the ocean like cars on an invisible highway. Modern flights now enjoy unprecedented flexibility in route planning, yet face new challenges from increasingly unpredictable atmospheric conditions. This transformation tells a remarkable story of how aviation adapts to both technological progress and the growing impacts of climate change on our planet. It's jet streams, the great system transformation. Until recently, transatlantic flights operated under the North Atlantic Organized Track System, a rigid framework that channeled aircraft through narrow corridors for safety and efficiency. However, this system has undergone dramatic changes that few passengers realize. Only 10% of transatlantic traffic now uses organized tracks, compared to 38% just a few years ago, marking one of the most significant shifts in oceanic aviation history. Since March 2022, all organized tracks at flight level 330 and below have been eliminated, granting airlines unprecedented freedom to request custom routes across the Atlantic. This transformation continued in April 2024 when traditional oceanic clearances specifying exact routes, altitudes, and speeds were completely phased out, ushering in a new era of flexible flight planning that prioritizes efficiency and fuel conservation over rigid adherence to predetermined pathways. Technology enabling freedom. This revolutionary change became possible through advances in satellite communication and GPS tracking technology that eliminate the communication blackouts that once plagued oceanic flights. Modern aircraft maintain constant contact with air traffic control through satellite links, allowing real-time monitoring and dynamic route adjustments that were impossible during the era of radio silence over the ocean. These technological breakthroughs have fundamentally altered how we think about oceanic flight safety and efficiency. The new system allows pilots and dispatchers to optimize routes based on current weather conditions, jet stream positions, and fuel efficiency calculations updated throughout the flight. This flexibility has resulted in significant fuel savings and reduced flight times, while maintaining the highest safety standards through continuous monitoring, communication capabilities that surpass the old organized track system as safety margins. The jet stream, nature's shifting highway despite technological advances. Transatlantic flights remain fundamentally dependent on jet streams, those powerful rivers of air that flow west to east at cruising altitudes. These atmospheric phenomena, flowing at speeds averaging 100 miles per hour in summer and up to 200 miles per hour in winter, continue to serve as nature's highways for eastbound flights, while creating challenging headwinds for westbound journeys. Understanding and utilizing these currents remains crucial for efficient oceanic crossings. Every morning, meteorologists and flight planners analyze satellite data to determine jet stream positions and incorporate this information into flight planning. Recent research reveals that these atmospheric rivers are becoming increasingly powerful and unpredictable due to climate change, with implications that extend far beyond flight planning into the realm of passenger safety and aviation economics. Climate change, the new turbulence reality. Recent scientific studies have confirmed what aviation professionals have been observing. Climate change is dramatically altering jet stream behavior in ways that directly impact flight safety and comfort. Research from the University of Chicago shows that the fastest jet stream winds are accelerating by approximately 2% for every degree Celsius of global warming, creating both opportunities and significant challenges for transatlantic aviation. While eastbound flights may become faster, the increased wind shear associated with these stronger jet streams is generating more frequent and severe clear air turbulence. Studies published in 2024 indicate that clear air turbulence will increase most dramatically over North Africa, East Asia, and the Middle East, with the probability of encountering severe turbulence rising with each degree of warming. This invisible threat poses particular challenges because it cannot be detected by onboard radar systems, making it impossible for pilots to anticipate and avoid these dangerous conditions during flight. The Boeing 787 incident. A wake-up call. The February 2019 incident involving a Virgin Atlantic Boeing 787 perfectly illustrates these emerging challenges. The aircraft encountered an exceptionally powerful jet stream that pushed its ground speed to 801 miles per hour, nearly 200 miles per hour beyond its normal cruising speed. While the plane did not actually break the sound barrier, the incident demonstrated how rapidly changing atmospheric conditions can create dangerous situations even for the most advanced aircraft. This event highlighted the growing unpredictability of jet stream behavior and the need for enhanced real-time weather monitoring and communication systems. It also underscored how climate change is creating conditions that aviation systems designed decades ago were never intended to handle, prompting a fundamental re-evaluation of safety protocols and flight planning procedures. Looking forward at adaptation and innovation, the aviation industry faces a complex future where technological capabilities continue to expand while atmospheric conditions become increasingly challenging. Airlines are investing heavily in advanced weather detection systems, improved turbulence forecasting, and enhanced communication technologies to maintain safety standards in this changing environment. The flexibility gained from abandoning rigid track systems provides tools to adapt to these new realities, allowing dynamic route adjustments based on real-time atmospheric conditions. However, projections suggest that severe turbulence could double or triple by 2050 to 2080 if current climate trends continue, potentially affecting flight schedules, routes, and passenger experiences across the North Atlantic corridor. The industry's ability to adapt through technology and operational procedures will determine how successfully commercial aviation navigates this climate-altered future while maintaining the safety and efficiency that millions of passengers depend upon daily. The story of transatlantic aviation continues to evolve as we balance technological innovation with the realities of a changing climate. These invisible highways in the sky, once rigid and predictable, now represent a dynamic challenge that requires constant adaptation and innovation. What are your thoughts on these dramatic changes to how we cross the Atlantic? Have you noticed increased turbulence during recent transatlantic flights? Join the World Documentaries community by subscribing to our channel for more explorations of how our world is changing in ways we rarely see. Share your flight experiences in the comments below. Hit that like button if this documentary revealed something surprising about modern aviation, and ring the notification bell to stay updated on our latest investigations into the hidden systems that shape our modern world.